Hello dear students, today's topic is the photoelectric effect. For this lesson we have three objectives. The first is to learn new terms related to the photoelectric effect. The second one is to understand the physical meaning of photoelectric effect. And finally, we will study the effect of light frequency and intensity on the photoelectric effect. The following terms are very important in this topic. First is intensity, the second one is remain, the next one is gain, then cutoff frequency, simulation, and effect. Here you can see the translations of each and every term. First of all, let's begin with the definition of photoelectric effect. So the photoelectric effect is the emission of electrons from a metal surface due to electromagnetic radiation. So basically, everything is shown on this diagram. So here, as you see, the light rays are coming here and giving some energy to the surface electrons that are located on the surface of the metal. These surface electrons are taking the energy and just flying out from the surface. This is called emission. Here we have the energy of the light. So if we denote the energy of the light as E and the kinetic energy of electrons as Ke, here we have another energy that has to be spent in order to make the photoelectric effect, and this energy, this work is called work function. Work function is the energy that is required to cut off the electrons from the surface of the metal. In order to tear the electrons out of the surface, we have to spend some energy. So it means that by the law of conservation of energy of the light is divided into two. So everything that I've said can be formulated in the following equation that is called the Einstein's equation for the photoelectric effect. So here E photon is energy of photon, this one is the work function, this one is the kinetic energy of the electrons or photoelectrons. From the Planck's hypothesis, we know that energy of photon is equal to h times frequency of the light. On the other hand, we know that kinetic energy has the formula of mv squared divided by 2. So the equation that is shown below can be opened as this one. Here the f is frequency and v it is the speed of the ejected electrons. In order to observe the photoelectric effect, the very important condition is that the energy of photon has to be bigger or equal to the work function of the metal. So the work function is something that is unique for each metal. For instance, in this table, we can see that potassium has the work function of 2.3 electron volts. It means that the energy of a photon has to be at least 2.3 electron volts in order to observe the photoelectric effect. We have to also know that 1 electron volt is equal to 1.6 times 10 to the power of minus 19 joules. This energy unit is used at this nanoscale because at nanoscale we have very small amounts of energy. Another term that we have to know is cutoff frequency. Cutoff frequency is the minimum frequency required to make a photoelectric effect. In order to calculate the cutoff frequency, we have to divide the work function of a metal by h, where h is Planck's constant, which is equal to 6.62 times 10 to the power of minus 34 joules times seconds. Now let's check the progress. So the first question is, a light beam with energy of 4 electron volts is incident on a sodium metal. Will the photoelectric effect be observed? Now you may press pause button and think about that. The answer for this question is yes. the energy of 4 electron volts is bigger than the energy of work function for sodium metal. The work function of sodium metal is 2.75, which is smaller than the energy of photon. That's why the photoelectric effect will happen. The next example, you may press the pause button and try to answer for it. The answer is no, because the energy of photon is smaller than the work function, which is not enough to make photoelectric effect. The next question, press the pause button and try to answer for it. The answer is yes, because the energy of photons is enough to make the photoelectric effect, because the work function is equal to 4.65 electron volts, which is equal to exactly the energy of photon. The next question is about solving the problem. In order to solve this problem, we have to know the formula, the Einstein's equation for photoelectric effect. So now let's calculate the energy of photoelectrons. You may press the pause button and try to solve this question. And the answer is 5.72 electron volts. I think the calculation is pretty enough. Here the energy of photon is 10 and the work function is 4.28, which can be found on the table. The next problem, a light beam with energy of 3 electron volts is incident on iron metal. What will the kinetic energy of photoelectrons be? The answer is the photoelectric effect will not be observed because the energy is smaller than work function. What will the kinetic energy of photoelectrons be? The answer is 2.7 electron volts. So now let's study how the light frequency affects the photoelectric effect. So here on the control panel we can see the wavelengths of the light. So here you can see that on this side we have infrared light, on the left side we have ultraviolet. So logically we can conclude that on the right side we have lower energy, on the left side we have higher energy electromagnetic wave. So if we move this adjuster to the left side, we will probably see how the light frequency affects the photoelectric effect. So let's see what happens if we are increasing the frequency. You probably noticed that the speed of the electrons has increased. That's why we can see that the higher the frequency, the more speed of the photoelectrons is. Now we will talk about the effect of light frequency to the photoelectric effect. So, the frequency of light determines the amount of photon energy. This is known from the Planck's formula. Also, the higher the frequency, the more photon energy is. And also, we can come up to the conclusion that the more photon energy, the more kinetic energy is gained. From this equation, we can see that the more frequency is here, the more velocity we will have. That's why these two properties are directly proportional. Let me explain how the intensity affects the photoelectric effect. So here we have the control panel of intensity. We can increase the intensity from 0 to 100. Now let's see what happens. So now the light intensity is 4%. And as you see, here we have something like 3 electrons that are flying out of the surface. But if we increase the light intensity up to 53, we see the rapid increase in the number of electrons. So we can see that the higher the intensity, the more electrons fly out from the surface. If to talk about the effect of light intensity, so the light intensity is like brightness. It shows the amount of energy from the light per unit area. For instance, if you use your phones, you can adjust the brightness by using this button. And according to the experiments, they show that the intensity of light affects to the number of photoelectrons, but it does not affect to the kinetic energy of photoelectrons. That's it for today. Thank you. In the next lesson, if you have any questions, you may write as a direct message to our Instagram account. See you. Goodbye.